Good morning, friends. So in this lecture, we are going to discuss about the elimination of left recursion. There are certain problems occurs in top-down parsing technique. They are backtracking, left recursion, left factoring, and ambiguity. So in this lecture, we are going to discuss about the left recursion. What do you mean by left recursion? If the non-terminal produces same non-terminal in the protection side, then it is called a left recursion. We will take one example. The grammar A, that is a non-terminal, produces the same non-terminal in the protection side, then it is have a left recursion for some string A, for some string alpha. So the top-down parsing technique cannot handle this left recursive grammar. So we have to eliminate the left recursion. There may be an immediate left recursion, there may be an indirect left recursion. We will see one by one. So how to eliminate the immediate left recursion? If the grammar A produces A alpha or beta, if non-terminal produces the same non-terminal in the protection side. So the non-terminal A having the different protections that A produces A alpha or A produces beta. So after eliminating the left recursion, our equivalent grammar will be A produces beta. So instead of this A, we are replacing with the other protection beta and introducing a new non-terminal as A dash. So A dash produces alpha A dash or epsilon. This is the protection, or this is the equivalent grammar after elimination of left recursion for the grammar A produces A alpha or beta. So in general, we can write the left recursion, that is elimination of left recursion will be if the grammar A produces A alpha 1 to A alpha m, or we have a beta 1 to beta m. After eliminating the left recursion, the grammar look like A produces beta 1 A dash to beta n A dash, and A dash will be the remaining symbols in the protection, that is alpha 1 A dash to alpha m A dash, and additionally we have to take a epsilon in the protection. So we will take one example, and we have a CFG grammar is displayed here. E produces E plus T slash T, and T produces T star F slash F, and F produces ID and open bracket E. So here E produces E, that is non-terminal E produces the same non-terminal in the protection. So this grammar is having the left recursion. Same way, T produces T star F. So non-terminal T produces same non-terminal in the protection. So this is also having a left recursion. But the non-terminal F produces ID and open bracket E, close bracket, that is not a left recursive grammar. So we have to do the elimination of left recursion for the non-terminal E and T. So after eliminating the left recursion, we will get the protection as E produces, because for the non-terminal E, we have two protections, E plus T slash T. So E produces T E dash, and E dash produces plus T E dash or epsilon. So based on the rule, after eliminating the left recursion, we are getting this protection. So we may have, if the left recursion, what are the other problems may occur in the left recursion? If the grammar is not immediately left recursive, but it is a left recursive grammar, how you can say that the grammar is not a immediate left recursion? For example, if you take this grammar, S produces A or B, A produces SC or D. By taking these two grammars, the grammar is not a immediate left recursion, because the non-terminal is not producing the same non-terminal in the protection. Again, if the A is not producing the same protection A in the protection side, but when we are replacing A with the other protection of A, that is SC or D, we will get the left recursion. That is called indirect left recursion. So in order to eliminate the indirect left recursion, we have to follow certain rules. First, we will take one example. So S produces AA or B, A produces AC or SD or F. So in that case, we have to order the non-terminals. So I'm ordering the non-terminals, S as first and A as second. So when we are doing the left recursion for S, we do not have any inner loop, because S produces AA or B. So there is no immediate left recursion for S. But for A, when I'm replacing A with SD, I'm replacing A with SD with A, then we will get as A produces AAD or BD, because we have A produces AC or SD or F. So we are replacing S with AA or B. So when I'm getting this, that is called a immediate indirect left recursion. So we have to do the elimination of the immediate left recursion, also a indirect left recursion. Then finally we will get a resulting grammar is this one. So for the same grammar, if I are taking the ordering of the non-terminals as A and S, then we do not have an inner loop for A, and then we have an inner loop for S. So at that case, we are replacing S, that is S produces AA will be replaced with the protection of A. What is the protection of A? What we have protection of A will have SD, SD A dash or A. So when I'm replacing S with SD A dash A, we will get a indirect left recursion. So after eliminating indirect left recursion, we will get the protection rule as like this. We'll have other example to eliminate the left recursion that A produces AB or D or AA or A. In that case, A produces A, and here also we have a left recursive grammar, and we have other protection of A is small a. So after eliminating left recursion, we will get that A produces small a, introducing a new non-terminal as A dash, and A dash produces the remaining symbols in the non-terminal A. Then we are getting this one. So that's all. Thank you.